So this is part 5 of lesson 2.4, friction. Our formula for friction is composed of three things: the frictional force, mu, which is the coefficient of friction, and the normal force. So you would find this formula on page 6 of your reference table. Okay, so as we know, FF stands for the force of friction, and our units are newtons. Mu, which is what that Greek letter is called, that just represents the coefficient of friction. That has no units, and we're going to see why in a second. And then the normal force is represented by Fn, and again, it has units of newtons, and that is a capital N in shorthand notation. So now, let's prove how the coefficient of friction has no unit. So, as we know, we have Ff equals mu Fn. If I wanted to get mu by itself, mu and Fn are held together by multiplication. In order for me to get mu isolated, I would have to divide Fn on both sides. It cancels out on the right. Then you would do F divided by Fn. Mu equals Ff over Fn. Again, remember the coefficient of friction does represent the ratio of smoothness. Essentially, a ratio is just a fraction, and that is what is shown here between the force of friction and the normal force. However, what's important to notice is that the unit for the normal force is Newton, and the unit for the frictional force is Newton, and the unit for the normal force is Newton. So when you have the same thing on top and bottom, they essentially just cancel out, and therefore no unit. Okay, so that only happens because newtons cancel out. Okay, so because the force of friction and the normal force have the same units when they are now, one is in the numerator, one is in the denominator, newtons will cancel out, leaving the coefficient of friction, quote unquote, naked because it doesn't have a unit next to it like most of our numbers do. So let's try an example. So an 8 Newton wooden block slides across a horizontal wooden floor at a constant velocity. The coefficient of kinetic friction of wood on wood is 0.3. What is the magnitude of the force of kinetic friction between the block and the floor? So I highlighted some important information. Just like we do in math, we underline the question so we know what's being asked. Let's show a free body diagram to tell us what's happening. So we have the gravity force down. We have a normal force upwards. It's going to be on some surface because a normal force requires there to be a surface since it is a contact force. This object is moving at constant velocity, which means that the magnitude or the length of the horizontal forces need to be the same. So I just like to give a heads up that FF and FA can go on either side. It's not saying that the frictional force can't go on the left side or the force applied can't go on the right side. They can flip back and forth. It's really just up to how you want to draw it in. So then once you write in a free body diagram, you would start your given process, or your guess process. So this 8 Newton wooden block, they're not saying that it is pushed or pulled, which means that that value actually doesn't represent a force applied. What it represents is the normal force. And if you remember this relationship, Fn equals Fg equals mg. I'm actually going to rewrite my g a little differently. Okay, so they gave us the normal force in this question. Okay, so this is the normal force. You could also say it's the force of gravity because they are the same magnitude, but for this formula that we need to utilize, we're just going to keep it as Fn. Okay, so our normal force is 8 newtons. Our coefficient of kinetic friction is 0.3, and we know it's kinetic friction because it is sliding, so it is moving. And they tell us, the coefficient of kinetic friction. All right, what they're looking for, which is the U, is FF. Okay, we don't know what that is. They say the force of kinetic friction. That just means that is the friction of the moving object. Okay, the formula that we're going to end up using is FF equals mu times Fn. We do substitution, so we don't know what FF is, but we do know 0.3 times 8 newtons, and we should get a frictional force for kinetic friction of 2.4 newtons. Okay, so it's pretty simplistic. When you see a paragraph, you highlight or you circle the key information, and then you underline the question, draw a free body diagram, and then you just do your givens. You just apply the guess method, and you'll be able to solve fairly easily. Okay, so this means that the answer is choice A. The other ones do not make sense. Okay, so now this next problem is a little different from the I do example, simply because now we're given a mass, whereas before we were given a normal force. So in the do now of this lesson that we saw on Thursday, there was a mass given, but at the time it wasn't important for us. However, now when we see a mass, most often mass is now going to be important. So again, let's read and annotate. A 0.50 kilogram puck is sliding across a horizontal shuffleboard court, is slowed to rest by a frictional force of 1.2 newtons. What is the coefficient of kinetic friction between the puck and the surface of the shuffleboard court? So here it's a little different, okay? Before we're going to draw our free body diagram. We always know that FG points down. I'm going to put in this surface right here. Again, we're not dealing with frictionless surfaces anymore. We are taking into account friction. Opposite my force of gravity is my normal force, okay? They want us to find the coefficient of kinetic friction, okay? So that's pretty important. That means that my object is still moving, which means that this slowed to rest is kind of there just to trick you, because we don't want static information. We want the kinetic information, okay? So because it is slowing down, that means my force of friction is going to be way bigger than my force applied, because friction just slows down an object. It does not speed it up. So if I was speeding up, then my force applied would be a lot bigger than my frictional force. So once we have our free body diagram, we are going to start our guess method. Okay, so givens, we have a mass of 0.5 kilograms. You don't have to write 0.50. If you want, you can, but if you don't, that's okay. As long as you put 0.5, that's the same thing as writing 0.50. Okay, so we have a mass of 0.5 kilogram. We have a frictional force of 1.2 newtons. Our unknown here is the coefficient of kinetic friction. We don't know what that is. However, going back to the last example, we needed this guy, which is the frictional force, mu, which is the coefficient of friction, and the normal force. So if we go back to our example now, we're actually missing the normal force. But that's okay because they gave us information that's rather important for us to calculate the normal force. So I'm going to label this E1 because this is going to be a two-step process here. So E1, I'm going to label it as Fn equals Fg equals mg. Okay? I'm going to label this S1. So we care about finding the the normal force. So we don't want to write Fg because that's not really important to us anymore. Just the normal forces, because once we have the normal force, then we can solve for the coefficient of kinetic friction. Okay? So we're going to do Fn equals 0.5 kilograms times 9.81 meters per second squared. We should actually be very familiar with this number. If you remember from kinematics, we used to do 1/2 9.81. So most of us by now should have this kind of memorized in our heads. So you would get a normal force of 4.905 newtons. All right, so now that you have a normal force, now you're going to have to do the second equation. So the second equation would be the frictional force equals the coefficient of friction times the normal force. So we're going to do our second substitution. So now we have 1.2 newtons equals mu k. I'm going to denote it as the k at the bottom, the subscript, simply because that's what they're looking for. It's okay if in the formula section or the E part, you don't put any subscript there, that's fine. But when we do the substitution, we are getting a little bit more specific, saying, hey, we're solving for the coefficient of kinetic friction, not static friction. Okay, So we put in 4.905 newtons. Don't forget that when you are substituting in this part, if you do not put your units in, you will not be receiving full credit. So in order to receive full credit, you would have to see this part and this part, okay, together. That's 1 point right there. And then another point is providing a correct final answer with appropriate units. So in order for us to get the coefficient of kinetic friction isolated, we are going to have to divide 4.905 newtons on both sides, 4.905 newtons, and this is our last part. So mu k equals, and if you plug this into your calculator, you would end up getting 0.24. Remember, the coefficient of friction is a unitless quantity, so if you write units after it, that's automatically wrong. This is the only time a number is allowed to be naked and it's acceptable, okay? And remember, the reason why it becomes a naked number is because my newtons cancel out, and so you're just left with the coefficient of kinetic friction of 0.24, okay? Another way you can check your work to make sure that you did it right, if you are to get a value where it is over 1, that means you did something wrong. You probably flipped the value. So if you did 4.905 divided by 1.2, you probably end up with some sort of mistake. So just check what numbers you're putting where, because that mu value always has to be between 0 and 1. All right, and finally, let's do this example. So I have a 20 Newton wooden box. It is sliding across a wooden surface. What is the force of friction acting on the box? So again, we're going to underline our question. We're going to draw a free body diagram. We'll make sure that, it makes contact. So FG is always pulling down. FN is always pulling up. So it is sliding across. So there is some sort of FA, and there is also some frictional force that we are going to solve for. Okay? So now that we did this lovely free body diagram, let's label our givens. So just like the first example we did, you have this 20 Newton box right here that's not an applied force, that's actually the normal force. Okay, so if you remember this relationship, Fn equals Fg equals mg, so that means that the normal force equals 20 newtons. Okay, we also have wood sliding on wood, which represents mu k, and that value is 0.30. Then you have an unknown, which is our frictional force. We don't know what that is, but we're trying to solve for it. The equation that you'd be using, just like all the other ones on page 6, would be FF equals mu times Fn. When we substitute, so remember, sliding means moving. That's why we're saying the kinetic coefficient of friction. So we're going to kind of denote that here. So the frictional force, we don't know what that is, but we know that this guy right here is 0.30. Again, unitless, so please do not put any units next to it, times the normal force of 20 newtons, and you should get a frictional force of 6 newtons. So not too hard, just following, what we see in the paragraph, make sure we're marking it up, and then we're just applying what we already know in terms of guess into the new formulas we learned for friction. That's it.